Right. Chemical props of alkenes. Alkenes. So what type of reactions alkanes will undergo? First one, halogenation. You know very well about this. We did in electrophilic substitution reaction. Sorry, free radical substitution we did halogenation. Chlorination, chlorination, bromination, iodination. What are the important points? What are the important points in that? It is what type of reaction? Which substitution? Free radical substitution, first point. Understanding? What is the second point? Fluorination is highly explosive. So it has to be done in inert atmosphere. Inert atmosphere. Right, children? It has to be done in inert atmosphere. And iodination is reversible. So what you have to do? Like these points you have to write. You have to done in the presence of oxidizing agent like HiO3 or Hg2O. Like this oxidizing agent is needed to done this. Oxidizing agent is required because it is reversible. So how can we overcome this reversible? By using a strong oxidizing agent. That's it. Now chlorination and bromination will be done normally only. So this is the main point. And one more important point in chlorination, what I told you, in the presence of sunlight it will take place. So you will get methyl chloride when this is excess. Okay. When chlorine is excess, what is the product form? CCl4. Understand, children? When methane is excess, methyl chloride will come, and when chlorine is excess, CCl4 will come. That's it. This is about halogenation. Any other point? No need, no. This we did. If methane is excess, methyl chloride is the main thing. If chlorine is excess, CCl4 is the main thing. Now, next one, nitration. Not more. All mechanism, everything if you know, it will take again 1 week for completion of alkanes, right? So important points only. Nitration. It is also what reaction? Important point, tell me. Free radical substitution? Yes or no? Free radical substitution reaction. It is a free radical substitution reaction. Next. If you take ethane or propane and HNO3 if you add, nitration. So how many products will come in nitration? 4 products will come. Right or not? 400 to 500 degrees centigrade. How many products will come, children? 4. Can anyone tell what are the 4 products? There is a chance of formation of 4 products. What are those? Here NO2 can come. So that is nitropropane. Nitropropane, children. Second one, 2-nitropropane also can come because there are 2 types of carbon, primary and secondary carbon in that. First one is nitropropane, second one is 2-nitropropane. Now this bond can break here. Then what are the products? This radical can form, ethyl radical can form, methyl radical can form. So in that case we can get nitromethane also. Yes. And one more thing, nitroethane also can come. Am I clear? So these are the 4 possibilities for nitration. Right? All possibilities. Any other possibility? You tell. Here it will cut. So this is also free radical substitution. Right. Third reaction. कोई दिक्कत? Correct only Hindi. Any doubts? Next one. Sulfonation. Sulfonation. Again, it is what type of reaction? First. Sulfonation is a what type of reaction? Again, free radical, right? Substitution. You will use here fuming sulfuric acid is the reagent. Fuming sulfuric acid. It is also called as oleum. It is also called as oleum. So suppose if I take alkane, alkane symbol RH and sulfuric acid, then you will get RSO3H and water molecule. Here OH will go, children. Sulfuric acid la OH and this H will go. These are easy only. In chemical reaction, only Friedel-Crafts is more important. Chance is there. Any doubt means tell them now. Doubt? Sulfonation, nitration. Next. These all reactions only for namesake. Only important thing is free radical substitute. Doubt? Next. Isomerization. Isomerization means what? One isomer will convert into other isomer. Just reagent you have to remember. AlCl3 is the reagent for that. And temperature around 200 degrees. AlCl3 and HCl around 200 degrees centigrade. Then it will form other isomer. This is N-butane to isobutane. Okay, 2-methylpropane. This is N-butane is converting into what? Isobutane. Next, immediately isomerism after, same like aromatization. Means normal thing convert into a aromatic compound. Reagent is only important, children. Reagent. You know this process, no need to explain. Al2O3 or Cr2O3 is the reagent and almost 500 degrees centigrade. 500 degrees centigrade is the temperature. So if you take N-hexane, means 6 carbon, 1, 2, 3, 4, 5, 6, 3, 4, 5, 6. This will give benzene, children. Benzene. And if you take a 7-membered ring, a 7-membered alkane, 1, 2, 3, 4, 5, 6, 7. Do means what? Ditto. Same reagent. You will get toluene, children. Because 7 carbons are there, no? That is why. Okay? This is easy reactions. Alkanes mainly concentrated on that halogenation reaction only. That is very important. Okay? Next one, you are aware of it, that is combustion. What do you mean by combustion? Combustion. Anything which burns in the presence of oxygen and liberates CO2 and water, right? Even alkanes also will do the same thing. Combustion. reacts with oxygen, gives rise to CO2 and water. Right? Any hydrocarbon plus some energy. So what type of reaction is it? Exothermic reaction. Combustion is what type of reaction? Exothermic reaction. So how to balance for combustion? First carbon, hydrogen, oxygen you do every time. So carbon, 1 is there, 1 carbon. Now hydrogen, how many are there? 4 are there. So write 2. Next oxygen, see children. Oxygens, how many are there? 4 plus 2, 6 are there. 2 plus 2, 4 are there. So it is 2. That's all. So suppose if I gave ethane, anything, or butane. So what is the thing you have to do? First write oxygen. Every reaction is same. Carbon dioxide plus water, like this you write. Every time oxygen is the reagent. But balancing this order you go, that will be easy for you. This order only. Carbon 2 are there. So 2 carbons. Hydrogen 6 are there. So 3 hydrogens. Oxygens, tell me how many will be there? Oxygens 7 are there, no? So 7 by 2 is right. 2, 2. If odd number, by 2. Even number, exactly you will get. Any doubt? Next one. C4H10 also. First write carbons. Next write hydrogens. Now how many oxygens are there, ma? 8 plus 5. 13 are there. So 13 by 2. If 14 are there, then 7 directly you can keep. Understand it? So this is the method to do the combustion reactions. Next, insertion reaction. Insertion means lower alkanes only will undergo this. Lower alkanes will be inserted in with the presence of carbene. Which will show insertion reaction, children? Carbene will show insertion reaction. Means suppose if you take butane, you will get pentane, children. You will get pentane. One CH2 group will be inserted in middle. So these are called as insertion reaction. Understand? Generally lower alkanes will undergo. This is butane, that is pentane. Lower alkanes only will go. Carbene insertion reactions. Last one, oxidation. Oxidation. So what happens when carbonyl compounds undergo oxidation? CO2, that is also oxidation only. But here some more products will be formed here in oxidation. Anyone remember? Yes, carboxylic acid and aldehydes also will form. Right, children? Alcohols also will form. Right, oxidation. Oxidation, if you take alkanes, whether RH or anything, 3 ways it will be. Reagent wise it will change. First one, oxygen in the presence of copper, if you take, you will get alcohol. You will get what? Alcohol. Alcohol is formed. And if you take molybdenum oxide, MO3O2, molybdenum oxide, M small o you write, M small o, MO2O3, small o. Molybdenum oxide you will get aldehyde, children. And manganese acetate. If you take manganese acetate, this is little tough to remember the reagents. But simply one thing I will tell you, acid. So oxidation, little reagents are difficult to remember, but anyway they won't ask, that is light on. Just simply alkanes and oxidation will give what? means aldehyde or alcohol or acid. So one sequence you have to follow. What is the sequence? This one. Alkanes, if you do oxidation, will form alcohol. Alcohols on further oxidation forms aldehydes. Aldehydes on further oxidation forms acid. This is the sequence. Now reverse same. Acids on reduction forms aldehydes. Aldehydes on further reduction forms alcohols. Right? So here again what is there? Primary alcohol will give aldehyde. Secondary alcohol on oxidation gives ketone. Secondary alcohol on oxidation gives ketone. Understanding? So this for this sequence I told this equation. Okay? Alkanes, if you do oxidation, you will get alcohols. Alcohols on further oxidation forms aldehyde. Aldehyde further oxidation forms acid. Right? So one more special reaction is there, that is syngas. What is syngas? Hydrogen peroxide, you didn't know. What is meant by syngas? CO and H2O, H2O. H2, sure. H2. Yes, H2O. H2 is only called syngas. So from methane you will get that syngas. Preparation of syngas. Methane plus water do, you will get CO plus H2. Total 6 hydrogens will be there. 4 plus 2, 6. See? Okay, Nara? Correct only? But here temperature is 1000 degrees. So this is called syngas. Okay. Now important points in this chapter is, what is CNG? Main constituent of CNG. What is the main component in CNG? Methane, compressed natural gas. So main constituent is methane. LPG, liquefied petroleum gas. Liquefied petrol gas. What is the main constituent? Butane. And some propane also will be there, but main is this. Okay? What is the main constituent of LPG? Butane. It is non-sooty flame, no? Non-sooty flame or not? Because blue color flame will come without any smoke. That is called non-sooty flame. We will use for cylinders. That's it. So this is alkanes part. Done. Alkanes part is done. We will move to alkenes. Fine.